A lot of people like to evaluate a model like this. This model feels pretty good, but in AI, feeling is the least valuable thing you can rely on. So how do we know whether a model is underfitting or overfitting? There's only one answer. You can't rely on intuition. You must measure it. This set of measurement rules is called model evaluation metrics. What are model evaluation metrics? They are a set of math-based measurements that tell you how good a model's predictions really are. In plain language, a model is not supposed to be smart-looking. It's supposed to be accurate. There are two main types of metrics. Type 1, regression metrics. Type 2, classification metrics. Regression metrics. Regression tasks are when a model predicts a continuous number, like housing prices, temperature, sales volume, time duration. The most core metric here is mean squared error MSE. MSE measures how far each prediction is from the real value. It squares the error, then averages it. Why square it? Because squaring amplifies the mistakes. The bigger the error, the harsher the penalty. So the smaller the MSE, the better the model. Classification metrics. Classification tasks are when a model chooses between categories like yes, no, normal, abnormal, pass-fail. In classification, the most common metrics are accuracy, precision, recall, and the confusion matrix. Accuracy. Accuracy is the simplest and most intuitive. It's the percentage of correct predictions. If a model makes 100 guesses and gets 90 rights, the accuracy is 90%. But here's the catch. Accuracy can be misleading. That's why we need the next concept, the confusion matrix. Confusion matrix. Think of a confusion matrix as a detailed right or wrong report. It splits the results into 4 categories: the true positive, false negative, false positives, the true negative. This table doesn't just tell you how many were right. It tells you where the mistakes happened. Once you have the confusion matrix, you can understand precision and recall. Precision answers this question. Of the things the model labeled as positive, how many are actually positive? In other words, how many yes answers were correct? Example, spam detection. If the model flags emails as spam, how many of those are truly spam? Recall. Recall asks the opposite question. Of all the actual positives, how many did the models find? In other words, how many true cases did the model catch? Example, disease screening. Out of all the real patients, how many did the model correctly identify? Summary. Model evaluation metrics exist to turn looks good gives into gives here's what's actually working and what's not. Without evaluation metrics, there is no basis for saying whether a model is underfitting or overfitting.